Okay guys, welcome back to Mr. C's Accounting, and today we're looking at amortization methods. So there are three common amortization methods that we're going to look at. The first is straight line. It is the most basic, but not always the best choice. Number two is declining balance. This one is more complicated, but it is the most accurate as far as matching goes. And the third is units of activity, and this is sort of the black sheep of the group because it operates on something other than time. So all three of these methods are acceptable from an accounting standard point of view. The trick is knowing which one to choose in order to give you the most accurate information and matching of costs. So select a method that best measures an asset's contribution to revenue over its useful life, and this will depend on the type of asset that you're amortizing. Now, once you've chosen a method, you need to apply it consistently over the asset's useful life. So you can't just swap methods whenever you feel like it. You've got to do your due diligence at the start, figure out which method is the best to use, and then go with that. So when you're doing amortization calculations, there are a set of givens that you need to know in order to correctly amortize an asset. So remember in mathematics where you, my teachers used to always tell me write down your givens, and at first I found it annoying, but now I find it very useful and I just use it habitually. So the givens that you're going to be working with, you may not get all of these, but these are the usual pieces of info that you need. Is the cost of the asset. In this example, we're looking at a vehicle. So this would be the historical cost to acquire the vehicle. Now, expected residual value or salvage value is an estimate of what you think the asset will be worth once its product life cycle is done. So after an asset has lived out its useful life estimation, this is the value that you could salvage the asset for. So if you bought a car and you used it for 10 years and then you decided to sell it, what do you estimate you can get it for? Now this is something that's usually estimated by either the accountant or an expert or just someone in the company who has relatively good knowledge about these things. It'll likely be based on estimated market values. For our course, this amount should be given to you, so you won't have to worry about actually estimating it. Now, the estimated useful life of the asset is how long you can actually use it for. Again, this is an estimation. Now, it's very common to translate your useful life into a useful rate. And this converts the useful life into a percentage that is applied to the vehicle cost every year. Not just vehicles, but in this case, we're looking at a vehicle. So the way this works is you take the estimated life and divide it by, or you just turn it into a fraction. So for example, if we believe that the estimated life is 5 years, we divide that 1 divided by 5 is 20%. So you just convert this into a fraction, or convert it into a rate such that the useful life is used up at the end of 5 years. So if, for example, if our asset's useful life was estimated to be 20 years, then our asset's useful life rate would be 1/20. Sometimes useful life can be given to you in units, and we're going to talk about that later. But in this case, you could say that the vehicle's useful life is 200,000 kilometers. That's not always the case. Again, these are just values that are made up for the sake of the example. So, straight line method. This is the most basic amortization method. The amortization cost is the same every year. and this measurement is made solely on the basis of time, and the actual calculation is quite straightforward. So the annual amortization expense is equal to the amortizable cost, which I'll explain in a second, divided by the useful life. Now, if you decided to convert your useful life into a rate, which you're welcome to do, then instead you would take the amortizable cost and multiply it by the percentage you got, or by the fraction that you got. So, for example, in our previous slide, we determined that the useful life was 5 years. So our rate is 1/5, or 20%. So you take your amortizable cost times 1/5, and that gives you your annual amortization expense. So going onwards, amortizable cost is equal to the original cost of acquiring the asset, the historical cost, minus the residual value, or the salvage value. So in this case, we got the vehicle for $25,000. We estimate that the residual value is $2,000. Therefore, the cost that is actually amortized or distributed over the course of the asset's useful life is $23,000. So this is the value that you will be amortizing. Therefore, the amortization expense in this case is the amortizable cost, $23,000, divided by the useful life, in this case 5 years. $23,000 divided by 5 is equal to $4,600 per year. Now, if you use the percentage method instead, it'd be $23,000 times 20%, or times 1/5, and it gives you the same value. So it doesn't matter which method you use whichever one makes the most sense to you. So amortization expense will be $4,600 every year using this method. Oh my God, sorry. So with the straight line method, this cost is incurred every year until the asset's useful life has ended. Now, the thing to watch out for with this method is when we're talking about ANMs, or annual expenses, such as the annual amortization expense, we're talking about the fiscal year. Now, usually, it's almost never going to happen that you're going to buy an asset at the start of the fiscal year. So when that happens, the amortization expense for the first year will not be $4,600. If, let's say, you bought it halfway through the year, then the amount of time that will pass over the course of that year is only 6 months. So this is annual amortization rate. So every year it will be $4,600. But in the case where you bought the asset halfway through the year, the expense would actually be half of this. So it would be $4,600 multiplied by the fraction of the period that's remaining after you bought it. So let's say that you bought the car a quarter of the way into the fiscal year, which means there are 3/4 of the fiscal year left. So then you would take $4,600 multiplied by 3/4, because you can only amortize it for 3/4 of the fiscal year, because that's all the time you had it for. So the first year wouldn't be 4,600. It would be whatever 4,600 times 3/4 is. So the declining balance method is method number 2. And it's called that because it produces a declining or decreasing annual amortization expense. So the reason for that is that amortization is based on a declining net book value, rather than just the original asset's cost. And so the NBV calculation is equal to the cost of the fixed asset, so that's the historical cost, minus the accumulated amortization. So the more an asset is amortized, the lower the net book value is going to be, and the higher this value is going to get. So one of the nice things about this method, although it is more complicated, is that the residual value is ignored. Now, at the time of purchase, the cost, the historical cost, and the NBV, the end book value, or net book value, sorry, are equal because no accumulated amortization has occurred. So when you first get something, it hasn't amortized yet. So the two values are the same. But after that, in the calculation, we're more concerned with the NBV than we are with the historical cost, and I'll show you what I mean. So as time goes on and amortization accumulates, the NBV becomes lower, and it becomes lower than the cost as soon as the first amortization is calculated. Now, the way that the amortization expense is calculated is using the percentage method, or the rate. So annual amortization expense is equal to the net book value at the beginning of the period times the rate. So here's a table that shows you what that looks like. So in this table is a series of amortization calculations that are conducted once every year in this case. And we start off with $25,000, which is the historical cost. And this is the last time we're going to use that number. After we use it for this calculation, and then after that, we focus on the net book value. So what we do is we start with the historical cost, and then we apply our amortization rate. In this case, it's 20%. And we apply that 20% to the historical cost. So 20% of $25,000 is $5,000. And what we do then to calculate the net book value, which is the amortization, or sorry, this is the historical cost minus the amortization expense. So $25,000 minus $5,000 is equal to $20,000. And then what we do is we take this $20,000 and we move it over here. And then from now on, we use the NBV to make our calculation. So we start with $20,000, our net book value from the previous period. We apply, or we find our amortization expense. $20,000 times 20% is equal to $4,000. And then to find our net book value, we take our original, or not our original, but our net book value from the end of last period, $20,000, minus $4,000 is equal to $16,000. And then we take our net book value from the end of the last period, transferred over here. To find our amortization expense for year 3, we take $16,000 times 20% is equal to $3,200. Now, $16,000 minus $3,200 is equal to $12,800. So that's our new net book value, which we transfer over here. 20% of $12,800 is $2,560. $12,800 minus $2,560 is equal to $10,240. And then we transfer that over here, and so on and so forth. So it's more complicated, but it's not all that complicated, if you know what I mean. Once it clicks, it's just, take the historical cost, find the expense, get the net book value, transfer, find the expense, new net book value, transfer, expense, etc., etc., etc. So, you may recall at the start of this video, I said that using the declining balance method is a better use, or it's better for matching principles. And the reason for that is that typically capital assets perform their best when they're first acquired. So it makes sense to assign a higher depreciation expense in the early years, because in the early years you're getting a higher benefit from the asset. For example, you guys you might have experienced this, but when you get a new car, or not a new car, but when you first get a car, hopefully you've inspected it or had it inspected to make sure that it's in good working condition. So typically when you buy a new car or when you buy a vehicle, it's in its best working condition when you first get it. And it runs nicely for a couple years, and then something happens. Like maybe the muffler gives out, or the brakes need changing, etc., etc. So you get the best performance at the beginning, and then as time goes on, the performance lessens because for some days out of the year, it needs to be in the shop being repaired, or maybe it doesn't function as well as it used to. And so it makes sense to match a higher expense with a higher contribution to revenue, if you see what I'm saying. So accounting is all about, and this is a point I've stressed before, but accounting is all about providing useful, valuable, relevant data, as relevant and useful as possible. And using the declining balance method accomplishes that. It just gives that much more clarity and clean matching between expense and revenue. And so that's why this is the most, it's the best method in terms of accuracy and relevance. Conversely, a lower depreciation expense is recognized in later years when an asset's contribution to revenue is less. And that makes sense. When an asset is contributing or generating more revenue, it makes sense to assign or recognize a higher expense to that activity versus later on when the asset is not contributing or generating as much revenue, we can assign a lower associated expense with it. And that makes sense. Okay, so this is the last method of amortization calculation, and it is called the units of activity method. And what makes this one interesting and stand out from the other two is that this does not focus on time. Instead, it focuses on total units of activity or production expected from an asset. Now, this is not applicable to all capital assets. For example, you wouldn't apply this to a building because it's pretty hard to tell what a unit of activity for a building is. But for things like vehicles, for example, or machinery, this could be more applicable. So, in terms of using this method, step number 1 is to calculate the amortizable cost per unit. So we start off with our amortization cost, which is found the same way that the amortization cost is found for the other two methods. So we have our total cost minus our salvageable value, and that gives us our amortization cost. So we find that in the exact same way. But then we divide that by the total units of activity. Now, the total units of activity is something that's estimated. It's very similar in concept to an asset's useful life. Like a piece of equipment that's designed to, say, compress pieces of metal together. There might be a way to estimate how many compressions it can do before it gives out. And that's something that would be estimated by the manufacturer. Most products actually have their useful lives estimated by the manufacturer. Actually, this is off topic, but something I learned the hard way is, when they talk about lifetime warranties for the product, that's not your lifetime. That's the product's lifetime. And the manufacturer in the warranty pamphlet will say what the lifetime of the product is. So, when a company or someone says, oh, it's got a lifetime warranty, well, that's great, but let's find out what the lifetime of the product is before we pop the champagne, So just a piece of interesting information. Okay, so step one, we found the amortization cost per unit. Step 2 is calculate the amortization expense. So the way we do that is we take our amortization cost per unit and multiply it by the units of activity during a period. So just to clarify, when I say amortization expense, I mean the amortization expense during a period, say a year. So there'll be an estimate of how many activity periods, or how many units of activity rather, would be in a period. So if we say that, let's say you have a moving truck. Moving trucks typically do a lot of driving on the highway, so they tend to travel quite long distances. So you could maybe make an estimate saying that in terms of the number of units of activity, if we say a kilometer is a unit of activity, then you might make an estimate that a moving truck would drive 200,000 kilometers or 200,000 units of activity during a year. And if you use that rationalization, then the amortizable cost per unit would be 23,000 divided by 200,000, which is 0.115 of a dollar per kilometer, or 11.5 cents per kilometer. And, I should say, finding the amortizable cost per unit is useful because it's very easy to find the associated amortizable cost with whatever number of units you're given. So, if it says, okay, we want to know what the expense is after 2,000 units, or we want to know now we want to know the expense after 10,000 units. You just multiply the units by the cost per unit to get the amortizable cost for those two different scenarios. So, if we assume that 45,000 kilometers were actually driven during the period, then our amortization expense for that activity during the period is 0.115 times 45,000, which gives us $5,175. So that's the amortization expense for the period given that number of units of activity. Now, the nice thing about this method is it's very adaptable to the product's usage, or to the asset's usage, I guess I should say. So the more you use the asset, the higher the expense is matched with that usage and with the revenue that asset has generated, which also makes a lot of sense, right? If for whatever reason, like for example with COVID-19 right now, a lot of businesses are using far less of their products, or their capital assets rather, than they normally would be. And so if they used the straight line method or the declining method, then that amortization amount wouldn't be as accurately matched to their revenue, because it looks like the asset is being used or contributing to revenues far more than it is. Versus this method is based purely on the asset usage. Now, obviously some assets aren't applicable, and different scenarios will warrant different methods of calculation. But what's nice is it makes the amortization calculation very flexible and adaptable to changing circumstances and changing usage of capital assets. So this method is not as popular as the others because it's often difficult to estimate total activity. For a car, it's fairly easy. You just look at the odometer and see how far you've driven. For machinery and stuff, you can estimate how many times it's being used, but that depends on the type of machine, right? So when the productivity of the asset varies quite a bit from period to period, this method results in the best matching, and that's what I was saying earlier. So again, depending on what kind of asset it is, just know that the big benefit of using this method is changing usability of the asset. And of course, the asset, or not so much changing usability, but changing usage of the asset. Now, of course, in order to benefit from this method, the asset's use has to be measurable, right? Like kilometers driven, or products assembled, or whatever other method of measurement that you can think of in terms of units of activity. Now, there is a great diagram that you should check out on page 470. It's illustration 10-12, and it just shows the process of the calculation. So check that out, super useful. In terms of the math involved, we have a simple example here. If you'd like to see a more complex example, then check out illustration 10-13, which is right underneath the other one. And it shows how the asset is, how the amortization is calculated over usage. I almost said over time, but it's not over time. It's over the usage of the asset. And also, if you're interested in comparing these three methods, Have a look at page 471. There's a graph on there, and it shows graphically how these different methods amortize these assets. And the visual reference is fairly useful. So have a look at that. It's pretty straightforward, but it's kind of neat to see what the graphical representation of this amortization is. Lots of Asians being used in this lesson. But anyway, that's it. That is our amortization lesson. And yeah, I will see you in the next video. Okay, bye.